Hello children. So welcome to AIMS India's online classes. Today from mathematics subject, integers topic we are going to learn. One minute children. So here. So today's concept is absolute value of an integer. Absolute value of an integer. Absolute value of an integer. So actually the absolute value of an integer, it is the distance of the integer from 0 on the number line. Suppose we have number line. On the number line, if the number line is integers number line, in the middle of the number line we will be having 0. On the right hand side we will be having positive values like 1, 2, 3, 4 and so on. And on the left hand side we will be having negative values -1, -2, -3, -4 and so on and so on. Like that we will be having different points on the integer number line, which represents different integers. So here, if we take any integer, its absolute value means its distance from 0. So its distance from the integer 0 will be called as absolute value of that integer. Means, suppose I want to find the distance of plus 4, or I want to find absolute value of plus 4. So how to calculate distance from 0? Distance from 0, how much? 1 unit, 2 units, 3 units, 4 units. Means the integer 4 is at a distance of 4 units from 0 towards right side. So its absolute value is 4. Whereas if you want to find the absolute value of -4, then what we will do? From 0, it is at how much distance? 0 to 1, 1 unit, 2 unit, 3 unit, 4 units. It is also at a distance of 4 units from 0, but towards left hand side. Here the direction is different. For while finding the distance of 4 or while finding the distance of -4, the direction of measurement is different, but the value is same. Here also 4 units, here also 4 units. Means the absolute value of plus 4 is 4 units. The absolute value of -4 is also 4 units. Why? Means absolute value is measured in terms of distance, which can never be negative. Okay. So the symbol for absolute value is pair of vertical bars. Inside the pair of vertical bars plus 4. What does it mean? Absolute value of 4 units. Absolute value of -4 is also 4 units. Means absolute value of any integer is always positive. So absolute value is always positive. That is one conclusion. Okay. So it is written as a pair of vertical bars. Next. So absolute value of a negative integer. Here we have to find the absolute value of -3. Means here absolute value is also read as modulus of -3. MODULUS. Modulus of -3. How much? That value we have to find. So here we will represent -3 on the number line. In the middle we will write 0. -3 means it will be written on the left hand side. 0 to -1, 1 unit, 2 units, 3 units. Means So distance, count the number of units, or count the distance of -3 from 0. It will be at a distance of, or count the number of units from 0 to -3. 0 to -3, how many units are there? 1, 2, 3. 3 units. Okay. Then absolute value of -3 is 3. Absolute value of -3 is 3. Like that, absolute value of a negative integer will be positive. Like that we can find. Next. So find the sum of modulus of -2 plus modulus of -5. We have to find their sum. Before finding the sum, we have to find their modulus, or we have to find their absolute value separately. Then we can do their sum. So absolute value of -2 is 2. Absolute value of -5 is 5. Means before finding the sum, here these two are considered as addends. These two are considered as addends. We have to find the absolute value of the addends. Then we have to find the sum. Now sum how much? 2 plus 5, 7. 2 plus 5, 7. So here absolute value is always a positive number, because it is the distance of number from 0 on the number line. Modulus of positive 0, 0. Modulus of negative 0, 0. Modulus of positive A, A. Modulus of negative A, A. Like that, either that given value is positive or negative, but the modulus is always positive. Modulus value is always positive. Next. So absolute value of a positive integer. Absolute value of a positive integer means like +3. If you want to find the modulus value of +3, let's represent +3 on the number line. So +3 means it should be written on the right hand side of 0. 1 unit, 2 units, 3 units. So count the number of units from 0 to +3 means if we count 1, 2, 3, 3 units will come. So absolute value is +3. Absolute value is +3. So if you want to find modulus of +3, we will write just 3 without sign. Without representing +3, just we can write it as 3. Modulus of positive integer also always positive. Next. It's okay. This sum already we have calculated. 2 plus 5, 7. Next. So here, absolute value of any positive integer or any negative integer is the number written without the positive sign, negative sign. Means they may ask the value of +3 or they may ask the value of -3. Without sign, without sign, just we can take the answer as 3. Just we can take the answer as 3. Okay. So this integers describe everyday situations. Everyday situations. If you want to find temperature, which can be above 0 or below 0, we make use of integers. Means if we go to a clinic, if doctor wants to check our temperature, or in laboratory, while doing the experiments, they have to do the experiments at certain temperature below 0. So while measuring temperature, we make use of integers like 0, 10, 20, 30, 40, 50, or -10, -20, -30, -40. It may be in degree centigrades, it may be in Fahrenheit, but while measuring temperature, we make use of these integers. Next. So powers of integers. Suppose if minus 5 into minus 5 into minus 5 into minus 5. So here minus 5 is repeated 4 times. Minus 5 is repeated 4 times. At that time, we can write it as minus 5 to the power of 4. Because as it is repeated 4 times, we can write it as, in terms of power, minus 5 to the power of 4, which is in the form of a power n, where a is considered as base and n is considered as power. Means the product of integers can be written in terms of powers, in terms of base and power. Base and power. Okay. Minus into minus, plus. Plus into minus, minus. Minus into minus, plus. 5 5 times 25, 25 5 times 125, 125 5 times 625. So value is plus 625. So any integer, if it has power 0, then its value is always 1. It may be positive integer or it may be negative integer. If we have 0 in the place of power, its value will be 1. Or any integer, if it has 1 in the power, 1 in the power, then its value will be same as the given integer. Minus 4 power 1 equal to minus 4, or 3 power 1 equal to 3. 3 power 1 equal to 3. Here, a should be non-zero rational number. A should be non-zero rational number. A should be non-zero rational number. One minute, children. Suppose if we have, one minute, children. Suppose if we have negative power, suppose a power minus n, then it can be written as, so 1 by this power will come down. This power will come down 1 by a power n. We can write like that. So 1 by a power 1, a power n, or if we have a by b whole power minus n, then it can be written as this a by b, numerator and denominator, we have to exchange their places, b by a whole power n. Here also, actually a power minus n means we can write it as a by 1 whole power minus n, because 1 to the power of any number equals to 1 only. Equals to 1 only. That's why a by 1 reverse means 1 by 1 power n by a power n, or 1 by a power n, or this is b power n by a power n. Like that, if we have negative power, then we can interchange the numerator and denominator. We can interchange the numerator and denominator. Then power sign will change. That is one condition. Suppose if we have, bigger numbers like 79,345, 79,345. If you have bigger numbers like this, actually the standard form of exponent is, it should be written in terms of 10 powers. It should be written in terms of 10 powers, and the base, the coefficient should be between 1 and 10. Between 1 and 10. Means in this way, if you have bigger number like this, then how to write it in the standard form means, so first means we have to separate the first one, extreme left digit, which is 7. We can write it as 7.9345 into 10 power 4. 7.9345 into 10 power 4. Like that we can write. Like that we can write in standard form. Means decimal point 1, 2, 3 places. Actually, 79345 point after we can keep zeros. Point after we can keep zeros. But for writing it in standard form, this point we are shifting towards 1, 2, 3, 4 places. We are keeping here 7.9345. Means as we have shifted 4 places towards left, we can take 10 power 4. We can write 10 power 4 here. And still it can be reduced. 7.9 we will write. Second digit, 1 minute. Second digit, as we have 3 here, which is less than 5, we can just strike it off. We can just strike it off remaining digits. Just 7.9 into 10 power 4 approximately. Like that we can write. Otherwise, if we have 7.4789, we can reduce it to one decimal place, like 7 point. Here we have 4. Second decimal is 7, which is greater than 5. We can strike it off. We can add 1 to it. 7.5. 7.5. Like that we can reduce it to one decimal place. So, okay. Means if we have negative exponents also, we can write. We can write in terms of positive exponents. If we have more place values also, then we can reduce to the standard form by taking the help of 10 powers. So here also 0.000054 means we want to keep this point after 5. Means 1, 2, 3, 4, 5 places. This decimal place has to shift 5 places towards right. Towards right. 1 minute, children. So here 0.000054. This decimal point we have to write in the form of 5.4. 5.4 means 1, 2, 3, 4, 5 places. It has to shift 5 places towards right. Means towards right we are shifting, means 5.4 into 10 power minus 5 we have to keep. If the decimal point is moving towards left, positive 10 powers we have to keep. If it is moving towards right, negative powers we have to keep. Negative powers we have to keep. Next. Next. So the power of natural exponent of an integer is another integer. Is another integer. So absolute value of the result is the absolute value of the base multiplied by the itself as specified by the exponent. So let's understand this by seeing the examples. So here the powers of even exponents are always positive. Means if you have plus of 3 whole square means we have even exponent here. We have even exponent. 2 is exponent, but it is even number. At that time, its value will be plus 3 whole square means plus 9 or minus 5 whole square. Here also exponent is 2, which is even. Power is 2, which is even. At the time also minus 5 into minus 5. So plus 25. Means if the exponent or power is even, if the power is even, you may have positive number as the base or negative number as the base, but result will be always positive. Otherwise, if you have odd exponent, means in the place of exponent, if you have odd number like plus 3 plus 2 whole cube, then its value will be plus 8, or minus 3 whole cube, its value will be minus 27, because minus 3 into minus 3 into minus 3, minus 27. If we have odd exponent in the place of power, if it is odd number, then if base is positive, result will be positive. If base is negative, result will be negative. Whereas in the case of positive exponent, the base may be positive, may be negative, result always positive. But here, if the base is positive, then only it is positive. If the base is negative, result is negative. That we have to keep in mind. Next, properties: a power 0, 1, a power 1, a. Multiplication, if they have same base, while doing the multiplications of powers, if they have same base, then we can add the powers for the same base. So multiplication of powers with the same base will be another power with the same base. Here a power m is a power with base a. A power n is power with base a. If we multiply these two, we will get one power with base a, whose power is sum of the other two powers. So a power m plus n. So here minus 2 whole power 5 they have given, into minus 2 whole square they have given. Both the bases are same. So we can write one time, and the powers we can add. 5 plus 2, 7. So odd. This is a odd power. So that's why it will be minus 2 power 7. How much? 128. Minus 128. Next. Division of powers with the same base. Here it is 5 children. 2 power 5. If they have same base, if a power m is a power with base a power n is a power with base a, then a power m by a power n is also a power with base a, where the power is the difference of two powers. In case of multiplication, it is the sum of two powers. In case of division, it is the difference of two powers. Means minus 2 whole power 5 divided by minus 2 whole square equals to minus 2 whole power 5 minus 2. One power is 5, another power is 2. 5 minus 2, minus 2 whole cube. So as the exponent is odd, here we will get minus 2 cube how much? 8. 2 cube how much? 8. Next, power of a power. Means we have power m, then again whole power n. If we have like that, means if a power m is a power with a power n is another power with base a. So a power m whole power n also a power of a, whose exponent is product of the two powers. A power mn. Minus 2, it is called power of power. Minus 2 whole cube whole square. We can multiply both. Minus 2 to the power of 3 2 times 6. 2 power 6. 6 means even number. So minus will become plus. 2 power 6 means 64. 2 power 6, 64. Next. So multiplication of powers with the same exponent. Means if we have same base, then we can add the powers. But now, if we have different base, but the exponents are same, powers are same, then what we can do? We can write as a product the given two bases. So product of bases whole power n, common power. Means, so while doing multiplication of powers with the same exponent, their base will be product of both the bases and power will be common power. Minus 2 whole cube, 3 cube. So 3 cube, powers are same. Minus 2 into 3, minus 6 whole cube we can write, which is equal to minus 216. Or division of powers with same exponent. If we have, if we have same base, a power m divided by a power n, a power m divided by a power n, a power m divided by a power n. So then what we have done, a power m minus n we have written. When they have same base, we can write like this. But when they have same power, a power n by b power n, we can write it as common power, a by b whole power n. Like that we can write. Minus 6 whole cube, 3 cube. Minus 6 cube, 3 cube. So minus 2 cube, we can write it as minus 6 by 3 whole cube. Minus 6 by 3 whole cube. 3 2 times 6. Minus 2 cube, which is minus 8. Which is minus 8. So regarding the exponents of integers, we have some laws. A power m into a power n into a power p. Bases are same. We can write one time, and powers we can add. That is first law. Second law, if the bases are same and we have division, base we can write one time, powers we can do the difference. Third law means power of power, a power m whole power n equal to both the powers we have to multiply, a power m into n, mn. Or we can write it as, we can exchange these two mn places, a power n whole power m. Like that also we can write. That is third law. So fourth law, if bases are different, exponents are same. So then for the result, their product will be the base, exponent we will write common exponent. Or fifth law, if the bases are different, exponents are same, we will write the bases as a quotient, exponent, common exponent we will take. These are the laws of powers of integers. And one more thing here. A plus b whole power n. A plus b whole power n equals to, suppose, 1 minute. Children. Suppose if we have, 1 minute. Suppose if we have a plus b whole power n. At that time, we cannot write like this, a power n plus b power n. We cannot write like this. We cannot write like this because these two are not equal. When we have product, we can write like that. But when we have addition, if we have common power n, we cannot make it equal to individual powers. That we cannot do. They are not equal. Even in subtraction also, if we have common power for subtraction, we cannot write it as a difference of individual bases. Like that we cannot write. Only in the case of multiplication, we can write like that, a power n, b power n. Or in the case of division, we can write a power n by b power n. But in the case of addition and multiplication, subtraction, we cannot do like that. Okay, children. That's all for today. So in tomorrow's class, we are going to solve some IIT-JEE problems relating to this concept. Thank you for watching our video, children. Please subscribe our channel and press the bell icon for receiving latest updates. Thank you. Have a good day.